Good morning. Myself, Dr. Umesh Sharma, in Mathematics Department, Associate Professor in Mathematics Department in Sanskriti University, Matna. Now we start my topics, successive differentiation. So differentiation again and again is called successive differentiation. So first is the derivative of first derivative of differentiation f dash x. We notification of f dash x is equal to dy by dx. D is the operator. D is the operator and say the notification. Second derivative is f double dash x, that is called by double dash, or we can written as by 2 d2y by dx square. So, or we can written as d2y. This is the second derivative. d2y by dx square is called second derivative of the differentiation. And so we find out the nth derivative f n x, or by to the power n, or by nx. This is called the nth derivative. So we differentiation again and again is called successive differentiation. So first we derive e to the power ax. So e to the power, suppose we take y is equal to e to the power ax and differentiation with respect to x by 1, that is equal to a e to the power ax, because differentiation of e to the power x, e to the power ax, e to the power ax, and again we differentiate a to ax, that is a only. So by 2, this is the second derivative. We again derivation of y1, that is called y2, a2 a2 e to the power ax. Let's suppose y is equal to e to the power ax. Now we differentiation with respect to x, that is called y1, differentiation e to the power ax, and the differentiation of a to ax is a. So the differentiation of y is equal to e to the power ax is y1 y1 is first derivative is equal to a e to the power ax. Now we find second derivative by 2, that is differentiation of e to the power x, e to the power ax, and differentiation of ax, that is only a, and a, that is a square. So by 2 is equal to a square e to the power ax. And we find same another differentiation, third derivative by 3, that is equal to a3 e to the power ax. Now the last nth derivative is called, now nth derivative of e to the power ax, that is equal to a to the power n e to the power ax. Similarly we find out the nth derivative of ax plus b to the power m. Now m is a positive integer greater than n. So y is equal to, first we take y is equal to ax plus b to the power m. First derivative of ax plus b to the power m, that is equal to m ax plus b to the power m minus 1. And then differentiation of ax plus b, that is equal to a. So we find out the first derivative of y, that is equal to by 1, that is equal to m a ax plus b to the power m minus 1. And second derivative of by 2, that is equal to m minus 1 a square ax plus b to the power ax plus b to the power m minus 2. And we find out similarly nth derivative is m minus 1, and last derivative is m minus n plus 1 a to the power n, because in first derivative we find the value is a, and in second derivative we find the value of a square, and the nth derivative we find out the value of a to the power n. Similarly this is in first derivative we find out the value of m, and in second derivative m minus 1, and similarly nth derivative, in third derivative we find out the value of m minus 1, m minus 2, a to the power 2, and ax plus b to the power m minus 3. And similarly we find out the nth derivative is m minus 1 and n time, that is m minus n plus 1, and a2 to a2 a3 and last an, and last point is ax plus b to the power m minus 1. So this is the derivative, and also this is the formula of y is equal to ax plus b to the power n, and find the nth derivative of ax plus b to the power m. Next, nth derivative of y is equal to log ax plus b. Log ax plus b, y is equal to a, Suppose y is equal to log ax plus b. Now we first differentiation with respect to x. Then we find the first derivative is y1 log x. The formula of log x is equal to 1 upon x. Then 1 upon ax plus b, and differentiation of ax plus b, that is equal to a. Or we can written as y1 is equal to a into ax plus b to the power minus 1. Now we differentiation again with respect to x, and then we find out the value of y2. Y2, that means second derivative. So a and minus 1 ax plus b to the power minus 2, and differentiation again with respect to x in ax plus b, that is ax plus b is equal to a, and we written as a square. So this is our second derivative. Now we find out the third derivative y3. That is in y3, similarly a square and a3, we find out the value of a3, and then minus 1 and minus 2, and then ax plus b to the power minus 3. Okay, so in last we find out the value of yn. Yn is equal to minus 1 to the power n minus 1, n minus 1 factorial, a to the power n upon ax plus b to the power n. Please check it. Y1 is this, and y2 is similarly minus a square ax plus b to the power 2. Similarly this one, and y3 is equal to 2 factorial. Y3 is equal to 2 factorial, minus 1 into minus 2. That means minus 1 to the power 2 into 2 factorial. This is equal to minus 1 into minus 2, minus 1 to the power 2 into 2 factorial. So y2 is equal to minus a square upon ax plus b to the power 2, and y3 is equal to 2 factorial a3 and ax plus b to the power 3. Is it clear? And so yn is equal to minus 1 to the power n minus 1, n minus 1 factorial, a to the power n, ax plus b to the power n. Is it clear? Because y3, if we have y3, that we find y2 minus 1 to the power 2, and similarly if yn, then we get n minus 1, n minus 1. Similarly y3, then we have 2 factorial, and in y4 we have 3 factorial, and y5 then we have 4 factorial. Similarly yn is equal to n minus 1 factorial. Now the nth derivative of y is equal to sine ax plus b. Similarly, we find out the value of sine nth derivative of sine ax plus b. How can we find it? So first assume y is equal to sine ax plus b, and then differentiation with respect to x. So y1 is equal to sine ax plus b. The differentiation of sine x is cos x. So cos ax plus b, and differentiation again with respect to x, ax plus b, that is equal to a. So a cos ax plus b. Now we convert it cos to sine. So a sine ax plus b plus pi by 2, because sine 90 plus theta is equal to cos theta. Similarly ax plus b taken as theta. So a sine ax plus b plus pi by 2. Now we second derivative of this one, then we get y2 as it is, a as it is because a is constant, sine, differentiation of sine is also cos. So cos ax plus b plus pi by 2, and differentiation of this one, then we get only a. So a and a is equal to a square. Now we find out y2 is equal to a2 sine ax plus b plus 2 pi by 2. And then in third derivative, aq sine ax plus b plus 3 pi by 2. And we find y4, fourth derivative. Fourth derivative is a to the power 4 sine ax plus b plus 4 pi by 2. And similarly find out nth derivative. Nth derivative is yn is equal to a to the power n. For nth derivative, a to the power n sine ax plus b plus n pi by 2. Is it clear? Then Similarly, we find out the value as y is equal to cos ax plus b. This is the derivation similar to sin ax plus b. Now we find the nth derivative of y, e to the power ax sin ax plus b. Now you see, first we take assume y is equal to e to the power ax sin bx plus c. Then first derivative is, first function is as it is, second differentiation of second function plus second function as it is, differentiation of first function. Now we start. So differentiation of first function, e to the power ax, that is a into e to the power ax, second function as it is, so sin bx plus c, plus first function as it is, e to the power ax as it is, and differentiation of second function, that is sin to cos bx plus c, and differentiation of b, that is equal to b. So we take e to the power ax r cos alpha plus r cos alpha sin bx plus c plus r sin alpha cos bx plus c. We put a is equal to r cos theta, that means r cos alpha, and b is equal to r sin alpha. For solving this derivative, we put the sum value a is equal to r cos alpha and b is equal to r sin alpha. Now we find e to the power ax r sin bx plus c plus alpha. So second derivative of this function is e to the power ax r1 to r2 sin bx plus c plus 2 alpha. And similarly we find the nth derivative of this particular function, e to the power ax sin ax plus b, that is e to the power ax r to the power n sin bx plus c plus na. So r square is equal to a square plus b square, because r is equal to a is equal to r cos theta, r cos alpha, b is equal to r sin alpha. So squaring both sides and add, so a square r square cos square alpha, b square is equal to r square sin square alpha, then a square plus b square is equal to r square cos square alpha plus r square sin square alpha. So r square taking as common, so we have r cos square alpha plus sin square alpha, that is equal to 1. So a square plus b square is equal to r square. This is the formula. R square is equal to a square plus b square. Now and tan alpha is equal to b upon a. If we divided b upon a, that means second divided from first, b to a, then r sin alpha divided by r cos alpha, r to r cancel out, then we have sin alpha upon cos alpha, tan alpha. So tan alpha is equal to b upon a. So this is the formula, tan alpha is equal to b upon a. Now we put all this value in this equation. So by n is equal to e to the power ax a square plus b square to the power n by 2 sin bx plus c plus n tan inverse b upon a. Similarly, we find out the next derivative, y is equal to e to the power ax cos ax plus b. We find out the nth derivative of this one, y is equal to e to the power ax cos ax plus b, that is equal to e to the power ax a square plus b square n by 2 cos bx plus c plus n tan inverse b upon. Summary of this results. So first we find out the value of y is equal to e to the power ax. Then the formula is nth derivative of by n is equal to a to the power n e to the power ax. Similarly, these all are the formulas, and learn all this formula to find the nth derivative. Now we start some example to solve the nth derivative. So find the nth derivative of 1 upon 1 minus 5x plus 6x square. So 1 minus 5x plus 6x square, this is a quadratic equation, and then we solve it. So after we solving this particular polynomial, we find out the value of 1 minus 3x into 1 minus 2x, and after the partiation, so we find out the value of 3 upon 1 minus 3x partial fraction minus 2 upon 1 minus 2x. So this is the result after the partial fraction. So this is the result, 3 upon 1 minus 3x and minus 2 upon 1 minus 2x. So this is the value of 1 upon 1 minus a plus bx and a plus bx. So what is the formula of 1 upon ax plus bx? This is the formula of ax plus bx, this one, ax plus b to the power n. So this is the formula, minus 1 to the power n, n factorial upon a to the power n, ax plus b to the power n plus 1. So this is the formula. So this one. The nth derivative behalf of this formula, we find out 3 minus 3 to the power n, because a is equal to a plus bx or ax plus b, minus 3x minus 3 is equal to b, a is equal to 1. If we put 1, a is equal to 1 and b is equal to minus 3, then we get the nth derivative of this particular fraction is this one, and the particular fraction is this one, is this one. This is the nth derivative of the formula after the putting the value. Now, second example, find the nth derivative of sine 6x into cos 4x. Sine 6x, sine c plus sine c cos d. This is the formula. So 1 upon 2 sine 10x plus cos 2x. So 6x plus 4x 10x and 6x minus 4x 2x. Sine a plus b plus cos a minus b. This is the formula. 1 upon 2 half of sine ax plus b, sine a plus b plus cos a minus b. So 6x plus 4x 10x, 6x minus 4x is 2x. So this is the formula. And we find out the nth derivative is particular function sine ax plus b. Sine ax plus b. What is the formula of sine ax plus b? Sin ax plus b. This is the formula of sin ax. Y is equal to sin ax plus b. And the nth derivative of sin ax plus b, y to the power n, a to the power n sin ax plus b plus n pi by 2. Now, in point of a is equal to 10 and b is equal to 0. B is equal to 0. Sin ax plus b, ax is equal to 10, b is equal to 0. We put a is equal to 10 and b is equal to 0 in this formula, then we get 10 a to the power n. A to the power n, that means 10 to the power n sin 10x plus n pi by 2. This is the nth derivative of this formula, sin ax plus b. Similarly, cos 2x, what is the formula of cos ax plus b? Cos ax plus b, a to the power n cos ax plus b plus n pi by 2. This is the formula. So we put a is equal to 2 and b is equal to 0 in the particular formula. Then we get 2 to the power n. A to the power n, that means a is equal to 2. So 2 to the power n cos ax plus b. A is equal to 2. So 2x plus n pi by 2. This is the formula. Now, third example of sin square cos qx. So let y is equal to this one, and we break out this function in cos square x into cos x. Cos qx, that is equal to, we some break this formula, cos square x into cos x. So sin square x into cos square x sin 2x, because sin 2x is equal to 2 sin x cos x. So we multiply and divide it by 4, then we get sin square 2x into cos x, that is equal to 1 upon 8 sin square 2x, that is 1 minus cos 2x, 1 minus cos 2x, because cos 2x is equal to cos 1 minus cos 2x, cos 4x, sin square 2x is equal to 1 minus cos 4x into cos x. This is the formula, and multiply by cos x, so cos x minus cos 4x into cos x, that is here 1 upon 8 cos x minus 1 upon 16. Similarly, the formula is cos 4x into cos x. So 4x plus 4x minus x, 3x. So cos 3x plus cos 4x plus x. This is the formula, cos 5x. Now, that is equal to 1 upon 16. We take the common LCM and then we find 1 upon 16. And 2 cos x minus cos 3x minus cos 5x. We have the formula cos ax plus b. Cos ax plus b is equal to a to the power n cos ax plus b plus n pi by 2. This is the formula. Now we see a is equal to 1, and similarly the formula, we use the formula cos ax plus b in second term. So a is equal to 3. Here a is equal to 3, and here a is equal to, similarly a is equal to 5. So we use the formula cos ax plus b. Cos ax plus b is equal to nth derivative of cos ax plus b, that is equal to a to the power n cos ax plus b plus n pi by 2. This is the formula. So we apply this formula in this particular terms, then we get 2 cos x. Cos x, that means b is equal to 0, a is equal to 1. So we get 2 cos x plus n pi by 2. Minus, similarly we use the formula in this particular term, then we get 3 to the power n cos 3x plus n pi by 2, and then last term we use the same formula in the last term, then we get 5 to the power n cos 5x plus n pi by 2. Now we start the next. This is the same example. Next we start, next topic is, this is exercise Leibniz theorem. This is very important theorem for the product of the derivation of the nth term. So this is the formula, basic statement of this Leibniz theorem. If u and v are the function of x such that nth derivative exists, if we have u and if u and v are the function of x such that nth derivative exists, then the nth derivative, this is the statement of Leibniz theorem, very important statement of the Leibniz theorem, and the statement is uv to the power n, u n v plus nc1 un minus 1 v1 plus nc2 un minus 1 un minus 2 v2, and then and so on. So now we use this particular Leibniz theorem in the example. Find the nth derivative of x log x. So this is our problem, x log x. Now we start u taking as x and log x taking as v. V is equal to x, v is equal to x and log x taking as u. Now we put all these value in the Leibniz theorem, then we get the result. So first we find out nth derivative, nth derivative of u log x, minus 1 to the power n minus 1 factorial upon x to the power n, and un minus 1 n minus 2 factorial upon x to the power n. Behalf of the formula, nth derivative formula as we before, then we find we find out the solution. So by Leibniz theorem we put u is equal to log x and v is equal to x in the Leibniz theorem. So this one, x log x to the power n. First u and v, first point is u and v. So minus 1 to the power n minus 1 factorial upon x to the power n x plus n into minus 1 to the power n minus 2 factorial x to the power n minus 1. So this is the formula of Leibniz theorem. This one is the formula Leibniz theorem. If we put the value of u is equal to this and v is equal to this, then we find the solution is this. Yes, this is very important example. Y is equal to a cos log x plus b is equal to sin log x. Show that x square by n plus 2 plus 2n plus 1 x by n plus 1 plus n plus 1 by n is equal to 0. So first we find out the value of by n plus 2. So by n plus 2, we find the value of by n plus 2. First we differentiation two time of y is equal to a cos log x plus b sin log x. After the differentiation of second derivative, we use the Leibniz theorem because we find the value of y n plus 2. So now we find y is equal to a cos log x plus b sin log x. This is the function that assume y. So in first derivative, y1 is equal to cos, the differentiation cos is minus sin log x, and then the differentiation log x is equal to 1 upon x. Then we have minus a upon x sin log x. Similarly, we find the first derivative of this second term, b sin log x, that is also sin the differentiation of sin x cos x. So cos and the differentiation of log x 1 upon x, and b as it is. So b upon x cos log x. This is the first derivative. Now again we take some LCM and then the left hand side. So x by 1 is equal to minus a sin log x plus b cos log x. Now we differentiation again with respect to x to find the second derivative. Now first derivative as it is, differentiation of second derivative by 1 to by 2 plus first differentiation of first derivative x, that is equal to 1. and the differentiation of second derivative, that is equal to by 1, same as it is. Similarly, is equal to differentiation of this function minus a sine, differentiation of sine log x cos log x, and differentiation log x, that is 1 upon x. So we find a minus a sine log x is equal to minus a upon x cos log x. This is the differentiate of sine log x. Plus similarly, we find the differentiate of b cos log x, that is equal to minus b upon x sine log x. So this is the second derivative. Now we applying this with the help of the Leibniz theorem. So the solution is, after we getting the second derivative, the solution is x square by 2 plus x by 1 plus y is equal to 0. So we use the Leibniz theorem particular term. Now we first applying the Leibniz theorem in first term, x square by 2. This is only the first term. We take the Leibniz theorem. So by n plus 2, we have the Leibniz theorem is this. Leibniz theorem is this one. uv to the power uv, nth derivative of uv, that is equal to unv plus nc1 un minus 1 v1 plus. Now we applying u taking as a value, v taking as in second value. Then we use this Leibniz theorem in the particular term. Then we get this one, x square by 2. So first term as it is, x square as it is, and differentiation nth term by n plus 2. First term as it is, x square as it is, and differentiation nth time. So by 2 is equal to by n plus 2. Now we use nc1, and again differentiation n minus 1 time. So by n plus 2 is by n plus 1. This is the differentiation n minus 1 time. So n plus 2 minus 1, that is n plus 1, and the differentiation of x square, that is equal to 2x. We use the formula x square x to the power n and x to the power n minus 1. So taking as 2 in the coefficient of x and 2 minus 1, that is equal to 1. So 2x, nc1 by n plus 1 2x, plus similarly we take the third term of this particular function nc2 by 2 n2. This is we use the Leibniz theorem is this term in first term. Now we again use in the second term in the Leibniz theorem. So x first term as it is, and the nth time differentiation of second term, that is by n plus 1 plus nc1 first term x differentiation of x, that is equal to 1, and the differentiation of n minus 1 second term by n and into 1. Into 1, that means differentiation of x is equal to 1. And now the nth derivative of by, that is equal to by n, is equal to 0. Now we collect and we take the common by n plus 2. By n plus 2 individual as it is, because there are no by n plus 2 in this line, in this equation. So by n plus 2 as it is, and then we take the some coefficient of by n plus 1. So by n plus 1 is here, by n plus 1 is here. So we have nc1 into 2x here and x is here. So 2n plus 1 into x by n plus 1. By n plus 1 taking as common and x is taking as common. So nc1, what is the value of nc1? That is equal to only n. And this is the coefficient of 2, then we get 2n is a coefficient of x by n plus 1. Similarly, the coefficient of y n plus 1 is here. So 1 is a coefficient of this one, plus n square plus 1. This is only the term 2 by n. First is here and second is by n is here and by n is here. Yes, by n is common. Then we get n plus 1. Now we take second example. Y is equal to log x plus root 1 plus x square, and then we have to prove that 1 plus x square by n plus 2 plus 2n plus 1 x by n plus 1 plus n square by n. Similarly, we find out the value of by n plus 2. By n plus 2. So first we differentiate 2 times of the given function. Then after it we use the nth derivative and using the Leibniz theorem. So first we find out the derivative of 2 times. That is second derivative. We find out the second derivative. So by is equal to this one, and the first derivative is by 1. we have to differentiate it with respect to x. So y1 is equal to log x. Log x is equal to 1 upon x. That means 1 upon this one particular portion, x plus root of 1 plus x square, and then differentiation of this portion, that is equal to x, differentiation of x, that is equal to 1, plus differentiation of this 1 plus x square is directly solution of 2x upon root 2 to 1 plus x square. This is the solution of root 1 plus x square. Now we solve it, and then we have the finally solution is of the first derivative is 1 upon root of 1 plus x square. So this is the first derivative. Now this one we take the LCM and take other side, then we get 1 plus x square by 1 square is equal to 1. Now we are squaring on both sides, then we get this solution 1 plus x square by 1 square is equal to 1. Again differentiation with respect to x, because we find out the second derivative, and after we find the second derivative, then the solution is 1 plus x square 2 by 1 by 2. Why we get this one? 1 plus x square as it is, and we differentiation by 2, 2 by 1 into by differentiation of by 1, that is equal to by 2, that is equal to by 1 square as it is, and the differentiation of 1 plus x square, that is equal to 2x is equal to 0. So we take the common term, some common term we have, common term is 2 common, and by 1 is common. So 2 by 1 is taking as common, and then to take this common term in the right hand side, then we get 1 plus x square by 2 plus x by 1. This is our second derivative. Now we applying the nth derivative rule, that means Leibniz theorem. We applying the Leibniz theorem of this particular area. So we have the Leibniz theorem is u v to the power n, that is equal to u n v plus nc1 u n minus 1 v1 plus nc2 u n minus 2 v2 plus nc, and so on. So we use this Leibniz theorem of this particular different types of term. First we use the Leibniz theorem in this term, then we get 1 plus x square as it is, and the nth derivative of second one by 2, that is equal to by n plus 2, this one 1 plus x square as it is, and we nth derivative of by 2, that is by n plus 2, and then first is nc0, nc1, nc2. Similarly we differentiate 1 plus x square, and after the first derivative we differentiate another time, so we take 1 plus x square 2x, 2x is the second derivative, and by n plus 1 we find the n minus 1 time differentiation by n plus 2, then we get by n plus 1. Similarly once again the differentiation nc2 by n plus 1 by n, and the differentiation of 2x, that is equal to 2. Now we start the differentiation again in a time with the help of the Leibniz theorem of second term x by 1. Similarly by n plus 1 x as it is, which is the first function, and differentiation of nth time by 1, that is by n plus 1 plus nc1 differentiation of x 1 of by n plus 1 by n. This is the uh, nth derivative of the with the help of the Leibniz theorem. Now we take some common part, and then we find this solution. This is the solution.